Chapter 6 of the Mind and Its Education by George Herbert Betts. Sensation. We can best understand the problems of sensation and perception if we first think of the existence of two great worlds, the world of physical nature without, and the world of mind within. On the one hand is our material environment, the things we see and hear and touch and taste and handle, and on the other hand our consciousness, the means by which we come to know this outer world and adjust ourselves to it. These two worlds seem, in a sense, to belong to and require each other. For what would be the meaning or use of the physical world with no mind to know how to use it? And what would be the use of a mind with nothing to be known or thought about? 1. How we come to know the external world. There is a marvel about our coming to know the external world, which we shall never be able to fully understand. We have come by this knowledge so gradually and unconsciously that it now appears to us as commonplace, and we take for granted many things that would puzzle us to explain. Knowledge through the senses. For example, if we say, "Of course I see yonder green tree. It is about 10 rods distant." But why "of course"? Why should objects at a distance from us and with no evident connection between us and them be known to us at all merely by turning our eyes in their direction when there is light? Why not rather say with the blind son of Professor Prézu of Paris, who, when asked if he would like to be restored to sight, answered, "If it were not for curiosity, I would rather have long arms. It seems to me that my hands would teach me better what is passing in the moon than your eyes or telescopes." We listen and then say, "Yes, that is a certain bell ringing in the neighboring village," as if this were the most simple thing in the world. But why should one piece of metal striking against another a mile or two away make us aware that there is a bell there at all, let alone that it be a certain bell whose tone we recognize? Or we pass our fingers over a piece of cloth and decide, that is silk. But why merely by placing our skin in contact with a bit of material should we be able to know its quality, much less that it is cloth and that its threads were originally spun by an insect? Or we take a sip of liquid and say, "This milk is sour." But why should we be able to, by taking the liquid into the mouth and bringing it into contact with the mucous membrane, to tell that it is milk and that it possesses the quality which we call sour? Or, once more, we get a whiff of air through the open window and in the springtime and say, "There is a lilac bush in bloom on the lawn." Yet why, from inhaling air containing particles of lilac, should we be able to know that there is anything outside, much less that it is a flower, and of a particular variety which we call lilac? Or finally, we hold a heated flat iron up near the cheek and say, "This is too hot. It will burn the cloth." But why, by holding this object a foot away from the face, do we know that it is there, let alone knowing its temperature? The unity of sensory experience. Further, our senses come through experience to have the power of fusing, or combining their knowledge, so to speak, by which each expresses its knowledge in terms of the others. Thus, we take a glance out of the window and say that the day looks cold, although we well know that we cannot see cold, or say that the melon sounds green, or the bell sounds cracked, although a crack or greenness cannot be heard, or we say that the box feels empty, although emptiness cannot be felt. We have come to associate cold originally experienced with days which look like one we now see, with this particular appearance, and so we say that we see the cold. Sounds, like the one coming from the bell, we have come to associate with cracked bells, and that coming from the melon with green melons, until we say unhesitatingly that the bell sounds cracked and the melon sounds green. And so with the various senses. Each gleans from the world its own particular bit of knowledge, but all are finally in partnership, and what is each one's knowledge belongs to every other one insofar as the other can use it. The sensory process to be explained. The explanation of ultimate nature of knowledge, and how we reach it through contact with our material environment, we will leave to the philosophers. And battles enough they have over the question, and still others they will have before the matter is settled. The easier and more important problem for us to describe is the process by which the mind comes to know its environment, and to see how it uses this knowledge in thinking. This much we shall be able to do, for it is often possible to describe a process and discover its laws, even when we cannot fully explain its nature and origin. We know the process of digestion and assimilation and the laws which govern them, although we do not understand the ultimate nature or origin of life which makes these possible. The qualities of objects exist in the mind. Yet, even the relatively simple description which we have proposed, many puzzles confront us, and one of them appears at the very outset. This is that the qualities we usually ascribe to objects really exist in our own minds and not in the objects at all. Take, for instance, the common qualities of light and color. The physicist tells us that what we see as light is occasioned by an incredibly rapidly beating of ether waves on the retina of the eye. All space is filled with ether, and when it is light, that is, when some object like the sun or other light-giving body is present, the ether is set in motion by the vibrating molecules of the body, which is the source of light. Its waves strike the retina. A current is produced and carried to the brain, and we see light. This means, then, that space, the medium in which we see objects, is not filled with light, the sensation, but with very rapid waves of ether, and that the light which we see really occurs in our own minds as the mental response to the physical stimulus of ether waves. Likewise with color. Color is produced by ether waves of different lengths and degrees of rapidity. Thus, ether waves at the rate of 450 billions a second gives us the sensation of red, 472 billions a second, orange, of 526 billions a second, yellow, of 589 billions a second, green, of 640 billions a second, blue, of 722 billions a second, indigo, of 790 billions a second, violet. What exists outside of us, then, is these ether waves of different rates, and not the colors as sensations themselves. The beautiful yellow and crimson of a sunset, the variegated colors of a landscape, the delicate pink in the cheek of a child, the blush of a rose, the shimmering green of the lake. These reside not in the objects themselves, but in the consciousness of the one who sees them. The object possesses but the quality of reflecting back to the eye of ether waves, of the particular rate corresponding to the color which we ascribe to them. Thus, red objects, and no others, reflect back ether waves of a rate of 450 billions a second. White objects reflect all rates. Black objects reflect none. The case is no different with regard to sound. When we speak of a sound coming from a bell, What we really mean is that the vibrations of the bell have set up waves in the air between it and our ear, which have produced corresponding vibrations in the ear, that a nerve current was thereby produced, and that a sound was heard. But the sound, i.e., sensation, is a mental thing and exists only in our consciousness. What passed between this sounding object and ourselves was waves in the intervening air, ready to be translated through the machinery of nerves and brain into the beautiful tones and melodies and harmonies of the mind, and so with all other sensations. The three sets of factors. What exists outside of us, therefore, is a stimulus, some form of physical energy of a kind suitable to excite to activity a certain end organ of taste or touch or smell or sight or hearing. What exists within us is the nervous machinery, capable of converting the stimulus into a nerve current, which shall produce an activity in the cortex of the brain. What results is the mental object which we call sensation of taste, smell, touch, sight, or hearing. 2. The nature of sensation. Sensation gives us our world of qualities. In actual experience, sensations are never known apart from the objects to which they belong. This is to say, that when we see yellow or red, it is always in connection with some surface or object. When we taste sour, this quality belongs to some substance, and so on with all the senses. Yet by sensation we mean only the simple qualities of objects known in consciousness as the result of appropriate stimuli applied to end organs. We shall later see how by perception these qualities fuse or combine to form objects, but in the present chapter we shall be concerned with the qualities only. Sensations are then the simplest and most elementary knowledge we may get from the physical world. The red, the blue, the bitter, the cold, the fragrant, and whatever other qualities may belong to the external world. We shall not for the present be concerned with the objects or sources from which the quality may come. To quote James on the meaning of sensation, all we can say on this point is that what we mean by sensation are first things in the way of consciousness. They are the immediate results upon consciousness of the nerve currents as they enter the brain, and before they have awakened any suggestions or associations with past experience. But it is obvious that such immediate sensations can be realized only in the earliest days of life. The attributes of sensation. Sensations differ from each other in at least 4 respects, namely, quality, intensity, extensity, and duration. It is a difference in quality that makes us say, this paper is red, and that blue. This liquid is sweet, and that sour. Differences in quality are therefore fundamental differences in kind. Besides the quality differences that exist within the same general field, as of taste or vision, it is evident that there is still a more fundamental difference existing between the various fields. One can, for example, compare red with blue, or sweet with sour, and tell which quality he prefers. But let him try to compare red with sweet, or blue with sour, and the quality difference is so profound that there seems to be no basis for comparison. Difference in intensity of sensation are familiar to every person who prefers 2 lumps of sugar rather than 1 lump in his coffee. The sweet is of the same quality in either case, but differs in intensity. In every field of sensation, the intensity may proceed from the smallest amount to the greatest amount discernible. In general, the intensity of the sensation depends upon the intensity of the stimulus, though the condition of sense organs as regards fatigue or adaptation to the stimulus has its effect. It is obvious that a stimulus may be too weak to produce any new sensation, as for example a few grains of sugar in a cup of coffee or a few drops of lemon in a quart of water could not be detected. It is also true that the intensity of stimulus may be so great that an increase in intensity produces no effect on sensation, as for example the addition of sugar to a solution of saccharin would not noticeably increase its sweetness. The lowest and highest intensity points of sensation are called the lower and upper limen, or threshold, respectively. By extensity is meant the space differences of sensations. The touch of a point of a toothpick on the skin has a different space quality from the touch of the flat end of a pencil. Low tones seem to have more volume than high tones. Some pains feel sharp and others dull and diffuse. The warmth felt from spreading the palms of the hands out to the fire has a bigness not felt from heating one solitary finger. The extensity of a sensation depends on the number of nerve endings stimulated. The duration of a sensation refers to the time it lasts. This must not be confused with the duration of the stimulus, which may be either longer or shorter than the duration of the sensation. Every sensation must exist for some space of time, long or short, or it would have no part in consciousness. 3. Sensory qualities and their end organs. All are familiar with the 5 senses of our elementary physiologies: sight, hearing, taste, smell, and touch. A more complete study of the sensation reveals nearly 3 times this number, however. This is to say that the body is equipped with more than a dozen different kinds of end organs, each prepared to receive its own particular type of stimulus. It must also be understood that some of the end organs yield more than one sense. The eye, for example, gives not only visual but muscular sensations. The ear, not only auditory but tactical. The tongue, not only gustatory but tactical and cold and warmth sensations. Sight. Vision is a distance sense. We can see afar off. The stimulus is a chemical in its action. This means that the ether waves on striking the retina cause a chemical change which sets up the nerve current responsible for the sensation. The eye, whose general structure is sufficiently described in all standard physiologies, consists of a visual apparatus designed to bring the images of objects to a clear focus on the retina in the foeva, or area of clearest vision, near the point of entrance of the optical nerve. The sensation of sight coming from this retinal image, unaided by other sensations, gives us but 2 qualities: light and color. The eye can distinguish many different grades of light, from purest white on through the various grades to the densest black. The range is greater still in color. We speak of the 7 colors of the spectrum: violet, indigo, blue, green, yellow, orange, and red. But this is not a very serviceable classification, since the average eye can distinguish about 35,000 color effects. It is also somewhat bewildering to find that all these colors seem to be produced from the 4 fundamental hues: red, green, yellow, and blue, plus the various tints. These 4, combined in varying proportions and with different degrees of light, i.e., different shades of gray, yield all the color effects known to the human eye. Herschel estimates that the workers on mosaics at Rome must have distinguished 30,000 different color tones. The hue of a color refers to its fundamental quality, as red or yellow. The chroma to its saturation or strength of the color, and the tint to the amount of brightness, i.e., white, it contains. Hearing. Hearing is also a distance sense. The action of its stimulus is mechanical, which is to say that the vibrations produced in the air by the sounding body are finally transmitted by the mechanism of the middle ear to the inner ear. Here the impulse is conveyed through the liquid of the internal ear to the nerve endings as so many tiny blows, which produce the nerve current carried to the brain by the auditory nerve. The sensation of hearing, like that of sight, gives us two qualities, namely, tones with their accompanying pitch and timbre, and noises. Tones or musical sounds are produced by isochronos, or equal timed vibrations. Thus, C of the first octave is produced by 256 vibrations a second, and if this tone is prolonged, the vibration rate will continue uniformly the same. Noises, on the other hand, are produced by vibrations which have no uniformity of vibration rate. The ear's sensibility to pitch extends over about 7 octaves. The 7-octave piano goes down to 27.5 vibrations and reaches up to 3,500 vibrations. Notes of nearly 50,000 vibrations can be heard by an average ear. However, these are too painfully shrill to be musical. Taking into account this upper limit, the range of the ear is about 11 octaves. The ear, having given us loudness of tones, which depends on the amplitude of vibrations, pitch, which depends on the rapidity of the vibrations, and timbre or quality, which depends on the complexity of the vibrations, has no further qualities of sound to reveal. Taste. The sense of taste is located chiefly in the tongue, over the surface of which are scattered many minute taste bulbs. These can be seen as small red specks, plentifully distributed along the edges at the tip of the tongue. The substance tasted must be in solution and come in contact with the nerve endings. The action of the stimulus is chemical. The sense of taste recognizes 4 qualities of sour, sweet, salt, and bitter. Many of the qualities which we improperly call tastes are in reality a complex of taste, smell, touch, and temperature. Smell contributes so largely to the sense of taste that many articles of food become tasteless. When we have a catarrh and many nauseating doses of medicine can be taken without discomfort if the nose is held. Probably none of us, if we are careful to exclude all odors by plugging the nostrils with cotton, can, by taste alone, distinguish between scraped apple, potato, turnip, or beet, or can tell hot milk from tea or coffee of the same temperature. Smell. In the upper part of the nasal cavity lies a small brownish patch of mucous membrane. It is here that the olfactory nerve endings are located. The substance smelled must be volatile, that is, it must exist in gaseous form and come in direct contact with the nerve endings. Chemical action results in a nerve current. The sensations of smell have not been classified so well as those of taste, and we have no distinct names for them. Neither do we know how many olfactory qualities the sense of smell is capable of revealing. The only definite classification of smell qualities is that based on their pleasantness or the opposite. We also borrow a few terms and speak of sweet or fragrant odors, and fresh or close smells. There is some evidence when we observe animals, or even primitive men, that the human race has been evolving greater sensibility to certain odors, while at the same time there has been a loss of keenness to what we call scent. Various sensations from the skin. The skin, besides being a protective and excretory organ, affords a lodging place for the end organs, giving us our sense of pressure, pain, cold, warmth, tickle, and itch. Pressure seems to have for its end organ the hair bulbs of the skin. On hairless regions, small bulbs, called the corpuscles of Meissner, serve this purpose. Pain is thought to be mediated by free nerve endings. Cold depends on end organs called the bulbs of Krauss, and warmth on the Ruffinian corpuscles. Cutaneous or skin sensation may arise from either mechanical stimulation, such as pressure, a blow or tickling, from thermal stimulation from hot or cold objects, from electrical stimulation or the form of action of certain chemicals, such as acids and the like. Stimulated mechanically, the skin gives us but two sensation qualities, pressure and pain. Many of the qualities which we commonly ascribe to the skin sensations are really a complex of cutaneous and muscular sensations. Contact is light pressure. Hardness and softness depend on the intensity of the pressure. Roughness and smoothness arise from interrupted and continuous pressure, respectively, and require movement over the rough or smoother surface. Touch depends on pressure accompanied by the muscular sensations involved in the movements connected with the act. Pain is clearly a different sensation from pressure, but any of the cutaneous or muscular sensations may, by excessive stimulation, be made to pass over into pain. All parts of the skin are sensitive to pressure and pain, but certain parts, like the fingertips and the tip of the tongue, are more highly sensitive than others. The skin varies also in its sensitivity to heat and cold. If we take a hot or very cold pencil point and pass it rather lightly and slowly over the skin, it is easy to discover certain spots from which a sensation of warmth or of cold flashes out. In this way it is possible to locate the end organs of temperature very accurately. The kinesthetic senses. The muscles, tendons, and joints also give rise to perfectly definite sensations, but they have not been named, as have the sensations for most of the other end organs. Weight is the most clearly marked of these sensations. It is through the sensations connected with movements of muscles, tendons, and joints that we come to judge form, size, and distance. The organic senses. Finally, to the sensations mentioned so far must be added those which come from internal organs of the body. From the alimentary canal we get sensations of hunger, thirst, and nausea. From the heart, lungs, and organs of sex come numerous well-defined but unnamed sensations which play an important part in making up the feeling tone of our daily lives. Thus we see that the senses may be looked upon as the sentries of the body, standing at the outposts where the nature and ourselves meet. They discover the qualities of the various objects with which we come into contact and hand them over to the mind in the form of sensations. And these sensations are raw material out of which we begin to construct our material environment. Only as we are equipped with good organs of sense, especially good eyes and ears, therefore, are we able to enter fully into the wonderful world about us and receive the stimuli necessary to our thought and action. 4. Problems in observation and introspection. 1. Observe a schoolroom of children at work with the aim of discovering any that show defects of vision or hearing. What are the symptoms? What is the effect of inability to hear or see well upon interest and attention? 2. Talk with your teacher about testing the eyes and ears of the children of some school. The simpler tests for vision and hearing are easily applied, and the expensive material almost nothing. What tests should be used? Does your school have a test card for vision? 3. Use a rotator or color tops for mixing discs of white and black to produce different shades of gray. Fix in mind the gray made of half white and half black, 3/4 white and 1/4 black, 1/4 white and 3/4 black. In the very same way, mix two complementaries, yellow and blue, to produce a gray. Mix red and green in the same way. Try various combinations of the four fundamental colors and discover how different colors are produced. Seek for the same colors in nature, sky, leaves, flowers, etc. 5. Take a large wire nail and push it through a cork so that it can be handled without touching the metal with the fingers. Now cool it in ice or very cold water. Then dry it and move the point slowly across the back of the hand. Do you feel occasional thrills of cold as the point passes over a bulb of krauss? Heat the nail with a match flame or over a lamp, and perform the same experiment. Do you feel the thrills of heat from the corpuscles of Ruffini? 6. Try stopping the nostrils with cotton and have someone give you scraped apple, potato, onion, etc., and see whether by taste alone you can distinguish the difference. Why cannot sulfur be tasted? End of Chapter 6. Sensation. Recording by Karima Ridout.